This week we'll be examining water quality, supply, and treatment. In fact, for the next several weeks, we'll cover the important concepts and issues in water pollution. This week we'll begin by examining the hydrologic cycle, as this cycle influences how we receive, use, and treat water. In the hydrologic cycle, water cycles through the atmosphere, then to Earth's surface via precipitation. It is channeled in surface runoff, it infiltrates to groundwater, is stored in the ocean and in underground aquifers, evaporates to water vapor, and starts the process once more. While it seems as if groundwater, aquifers, and surface waters are separate, in fact 80% of surface water comes from groundwater aquifers. There are many sources of pollutants to surface and groundwater. Normally, a single discharge point, a pipe or conveyance, such as industrial and municipal discharge, is the source. These point sources discharge and they're permitted under the Clean Water Act. Another important source of pollutants to our waterways is from non-point sources that are diffuse and usually land use related. We'll get into non-point source pollution in week 4. Typical water pollutants include oxygen-demanding substances, heat, infectious agents, plant nutrients causing eutrophication, toxic substances, petroleum-based chemicals and oil spills, and sediment from storm events. The most serious impact to an aquatic environment is the depletion of oxygen, as it is essential for higher forms of aquatic life. Excessive nutrients in the form of fertilizers from farm fields encourage plant growth in streams, and as they die and decay, bacteria necessary for their decomposition use up available dissolved oxygen, and fish kills result. Oxygen depletion can be calculated based on the amount of oxygen consumed versus that resupplied to the stream. The more rapid flows and the churning over rocks in healthy streams, known as riffles, pull in oxygen from the atmosphere. The lack of these features in lakes makes them more prone to eutrophication. Water sampling methods have become more sophisticated, and special protocols are available to assure scientifically meaningful results. Typical parameters measured include physical, chemical, dissolved oxygen, biological oxygen demand or BOD, COD, turbidity, color and odor, alkalinity, solids, nutrients like nitrogen and phosphorus, bacteria, viruses, metals, and trace organics. Water treatment for drinking water mimics natural processes. For instance, soil provides a natural filtering of water passing through it. Treatment plants use sand filtration for the same purpose. Additional processes include mixing, flocculation, settling, filtration, disinfection, fluoridation, and finally storage and distribution to the customer. Water safe to drink is termed potable.